Jai Hind. I am Dr. Aditya Pratap Singh, Associate Professor in IT Department. Today we are going to discuss the very interesting topic in C programming, arrays and pointer. So this will be a series of concepts related to arrays and pointers, and today is the first part of this series. This lecture belongs to the subject programming for problem solving. It is taught in first semester as well as in second semester of BTech program. So let's start with the journey. What is arrays? First we start with array, then we will move on to pointer part. So the basic concept related to pointer is that sometimes we require a similar kind of elements to be used in an application. These data items can have some common characteristics, can belong to similar type, but multiple such data items are required. For example, sometimes in mathematics problems, we require variables like x1, x2, x3 up to xn. So these all x1, x2, x3 belongs to same category. So in such cases, if we require any series of elements of same type, then how it can be done or how it can be used in C programming language. For example, if I want to store the height of students in my class, then in that case, either I am having an option to create n number of variables belonging to each students. Like if for example, I am having 60 students in my class, and in this scenario, I need to create 60 variables, but that will not be a good logical optimized solution, because to create and remember all these variables, it doesn't solve the problem in an efficient way. So for such requirement, there are some data structures available which can be utilized to program to solve a problem. These data can be stored in a way like what similar kind of collection of similar data type. For example, if we take example here, these are the books. So this is a collection of books. That book may be hard-binded book, that book may be paperback book, but they all belong to same class. That class is book. So the number of books that we have, we can say like this is an array of books. So array, we are saying the similar kind of data items, similar kind of items which are collected in a sequential order, that becomes an array. Like for example here, this is array of leaves. These leaves may be of different color, these leaves may be of different size. That is the value of their characteristic, but these all belongs to a same class, leaves. So here we have collected leaves and we can say that this is an array of leaves. Similarly, we have array of trees, array of flowers. So I hope now you understand the concept what we are calling an array. So let's try to understand that array can be of different dimensions also. For example, if we have one dimension array, that is a vector like entity, and in that there are certain elements. For example, here we are having A, B, C, D. These characters are stored in contiguous memory location. So that creates an array. We can have data in the form of table in row and column adjustment. So row column type of data that can be said like it is having x and y axis. So there are two dimensions. So we will call it 2D array. Sometimes we may require a 3D array. So 3D, in case of 3D array, for example, like if I want to store the rain it at a particular place on a particular date. So we are having 3 dimensions, the rain quantity, the date and the place. So we would require a 3D array kind of data structure to store such data. Now let's try to understand what array exactly is. So in case of arrays, array are example of structured data. We are saying structured data because we are storing the data in a structured manner, and the language, in C language, the array referred to structured data types, secondary data type, because we will create arrays with the help of some primary data type. That's why we are calling array as secondary data type. Array is a data structure which represents the collection of data items, collection of similar data items, and they will be stored in a contiguous memory location also. Now an array lets you declare and work with a collection of values of same type. For example, here you can see this is how arrays are stored. We are having one array of size 5. That means there will be 5 consecutive memory locations will be stored, and each consecutive memory location will be of the size that is required to store one element. Like here, if I require character type data, like in previous example I was having this ABCD, so these are character type data. So in that situation I want to store like 5 characters, so I can store 1, 2, A in 0, B, C, D and E. So these are characters. These all are characters. So character require one byte of memory. So they will be stored in consecutive memory locations. It is of size 5 and the arrays are ordered collection. So that's why we are having indices, or sometimes we also call it subscript. So these subscripts starts from 0. So at 0th location A is there, first location B is there. So that's how it is being stored. But for example, like if I want to store some other data type, I want to store integer values. So in that situation, if I want to store integer values, then I'll store integer here. So like I want to store I want to store 34 here, 20 here, 43 here, 61 here and 5 here. So I have stored some integer values. Now I hope you remember that how much memory is required to store one integer. An integer requires 4 byte of memory. 4 byte of memory for integer is required. So one element will be stored in 4 bytes. In that situation, the consecutive bytes will not be available for elements. One byte will store one number will be stored in 4 bytes, another number will be stored in 4 bytes. So the size in that case will become 40 bytes rather than 5 bytes, and 4 byte for 0th location element, then next 4 byte for first element, then next 4 byte for second element. So this is how it will get stored. That's why we do not say continuous memory allocation, rather we say contiguous memory allocation. So if I talk about the definition of array, a very standard definition is an array is defined as finite ordered collection of homogeneous data stored in contiguous memory location. So we have discussed why we are calling it contiguous memory location. We are saying contiguous because every consecutive byte is not going to store the same element, rather an element may require more than one byte to store. So the address of each element will not be in continuous manner. That's why we say it contiguous memory allocation, because 4 byte, then next 4 byte, then next 4 byte. For example, like if I want to store the double data type elements, then we would require 8 bytes for one element, then next 8 byte will be the place for next element. Let's try to understand each keyword available in this definition. What is the meaning of finite? Finite means whenever we are going to use an array, the size of array is necessary to be defined. We cannot say that I am declaring an array of type character, but I am not giving the size. So there will not be possibility to store what amount of memory will be stored or reserved in the memory by the compiler. So in that situation, it is not clear, it is ambiguous. Compiler will not reserve any memory. That's why it is mandatory to provide a fixed size at the time of declaration of an array. So this is the meaning of this finite. Every array has a fixed size. Next thing is ordered. Ordered means every element is stored in an order. Every element is being followed by a specific order, or they are being allocated at a particular location that can be find out with the help of index or subscript. So that's why we are calling it ordered. Like this 20 is stored after 34. This 20 is stored after 34. That means the index of 20 is 1 and index of 34 is 0. So that's why we are calling it ordered. And another thing is homogeneous. Why we are calling it homogeneous? We are calling it homogeneous because the arrays are allowing the similar kind of data to be stored. For example, I can have a character array, I can have an integer array, I can have a double array. So these kind of collection can be created, but array elements, every element of array will be of same type. That's why we are calling it homogeneous data. Okay. So as far as the types of arrays are concerned, in the C programming language, we can, in a broad sense, we can typecast it in two types. One is the single dimensional array or 1D array, that is vector like entity. All elements are stored in a sequential order. And another is multi-dimensional array. If we require more than one vector array type data, then in that situation we will create more than one dimensionality array. So these arrays may be 2D array, these may be 3D array, and if required, we can create more 4D and 5D. So these kind of arrays we are going to use in C programming. So let's start how to declare simple 1D array. Let's start with the 1D array. So an array is stored in an ordered manner. So every array has a subscript, and this subscript is used to access a specific element in an array. Every element has a index associated with it. That index can be accessed or can be used within the subscript operator, that is these large brackets we can utilize. Like I can write like xi. So I am referring the ith element in an array named as x. So like if I am saying yij, so I am referring a 2D array because two subscripts are there, 1 and 2 subscripts are there. Then in that situation, that is clear that it will be in row column form, and I am referring the element in ith row and jth column. In this situation, I am referring an element in a 2D array in ith row and jth column. So here I is being referred for row and j is being referred for column. So pointers and arrays are closely related because arrays make use of pointers internally. This is a very good concept, and we must understand that internal working of compiler uses the pointers. And a very interesting thing is that the name of an array also can be treated as a pointer. We will explore this concept in coming lectures, but today we are exploring the basic concept of array, how arrays can be declared, how arrays can be defined, how arrays can be utilized, and some concepts related to array. So in 1D array, I have already told you that we are having a single dimension and we will have a list of values in a linear form. So that will be treated as 1D array. Now how to define an array? I am referring this lecture as a very basic lecture for the students who have just started studying C programming. So arrays are defined in a manner that they are ordinary variable, but as they are collection, so we need to define its size. The size is defined with the help of the large brackets. So the syntax for declaring or defining an array is, first we may use storage classes. I hope you remember what were the storage classes. Storage classes are responsible for the scope, lifetime and memory location of a variable. If I remind you, and there were 4 storage classes: auto, register, static and extern. So these were 4 storage classes we were using. So we can utilize, if we will not specify the storage class, then it will take auto as a default for local variables. Then the type of array, what type of data we are going to store in that array, like int, like float, like character or any other type also. This can be used for structure type also and many other types also. So then the name of the array, just simple an identifier just to specify that array. And here is one expression this expression will evaluate it to an integer value, and that integer value will become the size of array. This is going to define the number of elements. It is going to define the number of elements in an array. So, let us see how it can be used. So, here a simple form of defining an array is data type, array name, size. We have omitted the storage class. So, that will become auto storage class. For example, int roll numbers 60. So, int is the type of data we are going to store. The name of array is roll numbers and 60 is the size. This is what? This is size. So, 60 elements we are going to store in roll numbers. Like in a class of 60 students, I want to store the roll number of all my students, then I can use this array. Another thing or another way of declaring and initializing the array. In this situation, I am declaring and initializing both. In this way, when we declared only the size of array, then the array elements or that size will be reserved in the memory area, and there will not be any kind of initialization. So, each element will have some random value, or we can say it will contain garbage value. Why it is garbage? I have already discussed in a previous lecture that whenever we reserve a memory space in the memory area, there will be some previous data into that memory area. If we are running programs, then there will be something stored in the primary memory, and we have stored a location in primary memory, then there will be previous sequence of 0, 1 is available in that memory location, and this will be evaluated to some value. Like if I have declared an integer variable, so I have declared an integer array. So, every 4 bytes will have some sequence of 0, 1, and that will evaluate to some numbers. So, that will become a random number or a garbage value. But if I want to declare and initialize, I want to declare as well as initialize at the same time. So, in that situation we can use like this, say, and we can initialize value with the help of curly braces and the values separated by comma. So, first value will be assigned to 0th subscript, next value will be assigned to 1 subscript. So, like this. For example, here I have declared a integer array named marks having size 6, and all the 6 values are initialized. So, that now it will not have a random number, it will have the values which I have already initialized. Another way of doing this is that we can omit the size. Whatever values I am providing, that will decide the size of the array. For example, here I am providing values. These are the values I have provided. So, 1, 2, 3, 4, 5, 6, the size of array will become 6. So, the values which we have provided will become the size of the array. Now, in another example, I may provide a string to a character array, that is allowed. So, I am providing BTech Smart class as a string to a character array and not specified the size. In that case, the size will be, the length of this string is 15, but the size will become 16, because every string contains a null character as a terminator at the end. So, 15 characters, and one character as a terminator will decide the size of array. So, the student name size will become 16. Okay. So, we have done how to define arrays like float marks 100. So, we can create a array storing the marks of 100 students. So, we can access this data using index or subscript. For example, if I want to access the marks of second student in my class, then in that case I can write like mark 1. So, 0 will be first and 1 will be the second student. So, I can access the element like this. Size and type of array cannot be changed once it is declared, because the memory has been reserved and there is no possibility as of now for arrays in C to grow or shrink. So, the size, and even we cannot change the type of array in running program. So, because that will also change the size. Every type has a different size, like integer has 4 bytes, double has 8 bytes, character has 1 byte. So, we cannot change, that will also change the size, but the total memory reserved is similar. So, we are not allowed to change the type or size of an array in a running program. So, arrays are stored like we can access x0, x1, x2. These are the subscript. With the help of these subscripts, we can get the elements. We can access the elements. These are some other examples, like we have declared an integer array, we have declared a character array. We can use the storage class here, and this is the type, message, and the length of message. So, we can declare like this, but some declarations are not legal, like I am declaring int n and I am declaring this marks n. N is not initialized yet. So, what data it will have, we do not know. So, what will be the size of marks? We are not aware. Nowadays, in the previous versions of compiler, this kind of usage was illegal, but nowadays we can do. But if we have initialized the variable n, then in that case we can declare marks n. But caution is n must be initialized before using in as a size. We cannot declare like this, because here no size is specified. So, what memory will be stored in memory, that is not that cannot be evaluated by the compiler. So, there will not be any possibility of creating such array. Every array is stored in memory in a contiguous memory location, we have already discussed. So, if k is the size of one element, then first array will be like at location x, name of array is a, and first address where the first element is being stored is x. So, x is the starting address, sometimes it is also called base address, and the next address, the address of next element will be x plus k, because k number of bytes are required to store first element. So, next element address will be x plus k, further next address will be x plus 2k. So, this is how it. So, basically C stores multi-dimensional arrays also in row major order. So, in multi-dimensional also it will be stored in row major, for 1D it will be stored in row major. We can find out the length of array if we are having an array already available. So, we can use this formula upper limit minus lower limit plus 1, that will be the size of array. For example, if I am having lower limit is 0 and upper limit is 7. So, in that case 7 minus 0 plus 1. So, that will be 8 will be the size of array. Or we can say in an array of size 8 we can declare elements from 0 to 7. So, that will become 8 elements. Now, there is a caution that while accessing array elements, the array bounds are not checked. In C programming, the compiler does not check for the maximum size of array. So, in that case, for example, like I have declared marks 5 and I am accessing or I am storing a value at marks 8 index. So, here there will be 0 to 4 index. So, maximum index will be marks 4, but we are storing value at marks 8. That will not give any error while compiling the program. It will be a logical kind of error because I do not know where this 8th element is stored. Maybe that location is given to some other variable which will change the value. So, such kind of assignment should not be used. It will not give error, but it should not be used. So, today we have completed the part what is array, how it can be declared, how it is being stored in the memory area. So, these things we have covered. Next, in coming next part 2, we will explore further important points about the uses of array. Thank you. Thank you everyone. Jai Hind.